Hey, good morning. Sumit on this side. Today we're going to talk about something that I've been talking to a few people, and I felt like the way that I prompt is a bit different. It's a little more nuanced, but at the same time, it's a little more simple once you let the idea sink in. And I felt like this would be a good time to talk about the prompting techniques that I have, more like at a very high level. How do I structure a project? So this is at a project level that we are going to talk about today, not exactly at like the modules or the specific features that I'm building, etc. And I hope that this comes to you as something very useful that you can use when you're building full stack applications. So the focus here is when you are building full stack applications, how do you structure the entire project, and what are some of the simple things that you do, some of the patterns that I've learned, where it makes it very easy, or let's say comparatively easier, to keep building with large language models, keep building with coding agents. So one of the first things that I want to tell you is that keep your names, so names of the folders, names of the files. If you're mentioning like folders, you're mostly mentioning because you're probably creating like backend and front end, and these are very established terms like mobile app, backend, front end, desktop app. These are extremely well established terms. So keep using those terms. If you're confused about a term, you can always search. You can always ask Claude separately, like, hey, I want to create this, something that at a very high level, maybe you have an idea for, maybe an API integration to something for the banking industry. And you can specifically ask, like, giving examples of what you want to solve, as in like what is the common naming convention for something like this, or even the subparts of that. So that's the first thing I want to talk about, is that we should name things in a way that they are easy for us in our minds when we are constantly talking about them. Because yesterday when I was talking about this with the founder, I realized that I have built up these over my experience, like over the last many years that I have been an engineer, which means that I have these common terms which are very helpful when I'm communicating either within myself, like I'm thinking about the process of what is this product going to be, what are the components in it, where are some modules, etc., etc. But it's also very helpful when I'm explaining to AI, when I'm explaining to the coding agents, what do I want to build next, or what do I want to scan within my project. So for example, let's say a few days after you have built some core feature or some additional feature, you come back and you say, hey, I forgot where this API integration exists, can you scan my code base and find that out? So it so happens that that API integration, whatever you're talking about, maybe that it's in the UI and it's talking to your backend, or it's in the backend and it's talking to the actual end service. And these can get very confusing because without that right context, you wouldn't know. So the naming really helps, because if you have very clearly like differentiated backend, front end, desktop app, mobile app, etc., and then even within mobile app, if you're doing like separate Android and separate iOS apps, then I would say those having their own folders, it helps immensely. But if you don't have separate iOS and Android apps, then of course one mobile app is good enough, but one web app, one backend, one if you have a web app or a front end, both work fairly fine. So that helps. And then the next step I would take is to think of the sub modules, the sub features in some of these. And I would really encourage you to think of breaking them apart. Like in my project in Nocodo, if you go to Nocodo, you will see, and I can show it to you either here or I can show it to you in my editor. Is that, and by the way, I'm just using the editor just to show, because I don't really look at the code as much anymore, which is fine, totally different discussion. But I want to show you that if you're looking at this, then you will see that the project has been divided. In fact, the last few days last few weeks, I've been dividing the project, particularly the backend, into more and more sub modules, more and more modules. And they are very important because they keep the like whatever is happening within a model is extremely constrained and extremely focused on solving that problem. So for example, nocodo talks to lots of large language models. Nocodo talks to lots of these AI providers, the AI models. And I thought, yeah, it makes a lot of sense for it to be an SDK. In fact, I've created a separate video about techniques that I used to build that specific SDK. There were very detailed prompts about it, very detailed features that I built within the SDK. But today I'm not going to talk about that. What I'm going to talk about is, why do I end up breaking? So my backend is called manager. Now, of course, then I'm conflicting what I just said as like very clear term. Manager is not a very clear term. Manager is to me like is the backend. So in this case, it works only because I always keep on referring in every prompt to the backend as manager. So there lies the consistency. To me, like your convention comes first as long as you keep doing it consistently. So that's very important. So to me, manager is very clearly manager because that's the role that I think of the backend in the case of nocodo. And that means if I keep on referring, so if I suddenly now refer as backend, I'm pretty sure things will get confusing. I don't do that. I keep on sticking to the word manager, and I've been doing this for the last many months, and I've had great results with all of my prompts. Doesn't matter if I'm researching or if I'm adding new features. And then you will see there's a mix of either manager dash something or nocodo dash something. Again, a little bit of confusion has entered. I'm still thinking through, and it's very important to think through these what we call nomenclature. So the naming convention, the nomenclature really matters because as you're going to build your project, you're going to make more subdivisions, make more modules. So in my case, I have manager models, which is a shared set of structures, code between the desktop app, between the native, like the desktop app that I have, the client app, let's say you could call it, and the backend, right? So between your front end and the backend, there is a set of shared code. There's a set of shared code simply because they are communicating between each other. So in my case, in my project, it makes a lot of sense for them to have, let's say, a shared code because it's like that's where the API gets generated from. And that is called manager models. Now, could I not have called it nocodo models? In my mind, it does not work out. Maybe I'll rename this to shared models or shared structs or something like that, which kind of clarifies that this is about sharing of actual Rust structures, like actual code in Rust. But at the same time, manager models feels like, given that models are also easily you can think of AI models, right? So this becomes a bit confusing, and I'm aware of this, which is why I'm talking about it today, is that I might change this in the future. And you have to constantly think about these things, is that because the way you talk, it's part of your process, and your process is the way you talk, right? They are intertwined. So the naming conventions come up again and again in your process, in how you describe the project, how you talk with large language models, how you talk with the coding agents. And no matter which coding agent you use, by the way, it does not really matter. If you're using Cursor, if you're using even Lovable for that matter, for UI work, it does not really matter what is your coding agent. At the end of the day, if you're going to stick to some conventions that you have built up, and if you're consistent about them, it's going to make your prompts that much better. So that's that. And then if you're breaking them apart, again, making sure that you're thinking through the naming. Okay, is my, for example, in my case, manager tools specifically is all those tools that agents use to work. So for example, are you talking to an API? Are you talking to your local files? Are you looking at the list of local files? Are you searching for something in your files? All of those are specific tools. If you open this up, by the way, all of this source code is open source, so you can feel free to go to this repository and check it out for yourself. This is open source as the project, everything is live out there, feel free to check it. But within the tools, everything is in its own folder. So everything that has to do with the file system, reading files, searching files, listing files, etc., is in the folder file system. And then this also relates to in the manager models. This is the shared structures, the shared code that is between the backend and the front end. There also, if you open up the folders, you will see that inside tools there is also file system. So the file system of the shared code that is between the desktop and the backend is the same file system that is also the file system tools, because the shared code goes into the manager models folder. Okay, now this may seem like, oh wow, this is overly complicated. Yeah, but no. But the reason they seem overly complicated is simply because it's the amount of stuff that happens in nocodo. So nocodo is a fairly complicated project by nature. It's a project which writes other projects, right? I mean, it's a code building system, right? It's a coding agent, and now it's becoming a full agentic platform, which means that it can take your idea and build agents, it can do evaluations, it can run tests, it can take your inputs, API keys and everything, and go and deploy the agent onto your cloud, which means it's doing a lot behind the scenes. And of course, you're controlling all of this from the desktop app. Everything has to work correctly, right? And all of this is generated code, which means I have to be so much more careful about the architecture and how I do stuff, which is what I'm talking about today. The high level patterns of how I prompt, not the specific details of the prompts, but the high level, right? So the structuring of the folder, creating these submodels, and making sure what is related to what submodule, right? So if, by the way, this you can do in any programming language. It's totally fine if you're building with TypeScript, with Python, with Ruby. It does not really matter. What matters is that you're latching onto these common conventions which are from the industry, which are from software engineering, but also how you think. They both have to merge at the same point, right? They have to come together, because if you don't do that, you'll either be prompting in ways that are just industry standard and you don't like it, or that means, by the way, that at some point you will fall off, right? Because you will simply, if you don't like the conventions, you'll be like, yeah, okay, I'll naturally, I'm changing to using other words because the words I used in the project are not my choice of words. So you have to be careful about that. Also, the reverse is true, is that if you use very common terms which maybe are great to talk about to say a non-technical person or to your team, but if it is very different from how we conventionally think of software projects, then it might also hurt on the AI side of things, the prompting side of things, right? So that's what I'm trying to clarify today. Okay, so then as you can see, I have manager tools, then I have manager agents. Agents is a completely new sub project I'm building. This is what you can think of is agents, right? So what are agents? Agents are basically a kind of code that you can let it be, and it has some sense of autonomy in which that it can create its own memory. It can keep track of things. It can keep track of whatever resources it has been given, and it can use a bunch of tools as well as AI models to run, let's say, in a loop. Okay, so you're waiting for customers' messages, an agent comes in, an agent looks at this customer, figures out the customer's ID, go checks a database, they makes decision with AI, like, do I need to answer this question right now? Do I need to gather some extra data? Blah, blah, blah. Do I need to maybe call the manager? Blah, blah, all of those things. That's an agent. That's an example of a concrete agent. Now, here my agents inside nocodo are a bit simpler than that, because I'm trying to create that's just my approach. The way I'm creating is have lots of agents. They're very focused on the specific goal that they are trying to solve. Still, they have autonomy, as in they can figure out and they can make these decisions along with AI models by themselves. But the agents have very specific goals, and then I want to mix and match these agents to build like bigger and bigger agents, so multi-agent systems. But that aside, what you can see is that agents is its own separate library. You could call it a library, a module, I don't know, depending on your programming language, depending on your tech stack, what do you call them? In my case, in Rust, we generally call them separate crates. And then all of these crates are actually referred to in here in the main cargo.toml file. So that's one, you could say, configuration file where all of these crates, all of these modules are referred to. And that's how in Rust you build up. But again, your programming language will be different, and you can ask AI about what is going to be the structure if I'm dividing. Now, then I have, of course, the LLM SDK, which is more easy to understand because I have a bunch of models I connect to. I have a bunch of providers I connect to. As you can imagine, if you look at the source, it's very easy to understand that I have like Claude, I have GLM, I have Grok, I have OpenAI models, right? I have a bunch of these models which I connect to, and some of these models I can connect to different providers. So Grok, for example, is provided both by xAI, which is originally like the Twitter's AI team or company, whatever you call it. And it is also provided by Zen. Zen is a model provider, which is the same company that is behind opencode, an independent coding agent. And they also provide a set of models. Zen also provides GLM. So if you go to GLM, you'll also see that I have ZAI as a provider. And I have ZAI is the original company that is behind GLM, the model. But I also have Zen as a provider. And then I have also Cerebrus as a provider, because Cerebrus also allows you to run GLM model. So there you can see that the reason why this piece of code, like this entire software, the LLM SDK, the one that talks to large language models. Of course, there are, by the way, existing libraries. I didn't choose to, simply because my communication with the LLMs is so deep, and it will need so many nuances that I chose to build the SDK, because for me that was not a tough job. I felt like it'll give me better benefits in the future. But that's up to you. You can use an existing SDK. That's not what we are talking about. What we're talking about is that if it makes sense for you to separate something out into its own library, let's say you're integrating to a bank API, and that bank API's output you're going to use as, whatever data that comes through, then you're going to talk to a large language model, an AI model, and then negotiate with the user, and then comes out your actual output in your web app, right? But the bank API integration, if you think about it, if you take a step back and like, yeah, the bank API integration actually makes sense to be separate so that I can test it. I can keep maintaining it as the API changes, or if something breaks, I can fix those, and it does not touch the rest of my code base. And that's a great way of thinking, because the more you take out these parts and you make them as independent components, modules, crates, however you talk about them, like in your programming language, it'll only help you. Because now the added advantage, and this I'll show you like this, is that the added advantage is that I can now simply go to my project. Okay, and by the way, I'm working on a separate Git work tree here, separate Git work tree branch, totally different thing, but just for the ones who have noticed this, that there is a work tree here. Okay, now what I can do is I have the entire project here, but I can drop into, let's say, the LLM, just the LLM SDK, and I can ask Claude specifically about the LLM SDK if something has gone wrong. Let's say my ZAI integration, maybe my OpenAI integration is breaking. I have tests, by the way, so you can also run the tests here. The way I run the tests is cargo run --bin, and these are going to run only the tests for the LLM. So there is a specific LLM test runner. I have a workflow test runner. So different sub projects have different test runners, and they use the configuration file for all my API keys. I'm of course not going to show all my API keys, but you can imagine they have all my API keys for OpenAI, for Anthropic, for ZAI, for whoever else, right? So now this test will run, but the added benefit I get is that now the context, if I want to fix something, if some test is failing here, I can drop into this particular folder and ask my coding agent to fix that particular thing, but it needs no context from the rest of my product, from the rest of like what is happening in the back end, front end. It will not even touch those folders. Of course, in some cases, your folders do have that library sharing, like because you're probably sharing something from a different folder into this folder. That can happen. But in this case, if this folder is mostly, if this project, if this subproject, the module, however that nomenclature is to you, if that is self-contained, in my case, this is API integration to the large language models, and this subproject does not need to care about any of the subprojects in my rest of my product, then it makes so much more sense that I drop into a shell as the tests are running. Let's say one of those tests fail, or let's say I wanted to, I don't know if you already know that Codex 5.2, the GPT 5.2 Codex model just got released. So what I can simply do is I can go to this folder and I can go to LLM SDK. And now here I can say, hey Claude, do you know about this new model that just got released? Like, because I'm in this folder, right? I'm in, if you see, I'm in the nocodo LLM SDK folder. So if I talk to Claude here, hey, I want to integrate the new GPT 5.2 Codex model that was released by OpenAI a couple days back. Please use web search to find docs. If our existing docs do not cover this model, so it should. Oops. We have external docs folder. I know that this folder exists, and by the way, if you have been following me, you already know that I no longer use a Claude.md, agents.md. I don't even use them. It's not necessary. For 2-line sentences, there is so much context already in my source code. It's so nicely structured that I do not rely on any agents file at all. I'm not joking. You can go and look into my source code and you will see that there is no agents file. Okay, there used to be, by the way. I used to have Claude.md. I used to have, I don't know, a bunch of other MD files, but I got rid of all of them. It's just not necessary because the models have become so much better. The harnesses, the agents, the coding agents have become so much better that you don't really need them. If your structure is just, growing naturally in a very well structured way, you don't need those agent files. Sometimes maybe, but I have not come across, and this product is really large and it's working so well. It doesn't really have problems. So why would I need one file, right? So we'll wait for this to finish while we go here. All my tests passed. So this is another thing, is that my tests are also very isolated. Okay. All of these things end up giving you more and more benefits when you're structuring the code. So we talked about 3 or 4 things here: nomenclature, naming conventions, foldering, submodules, etc., and then being able to drop into that subfolder, asking Claude, or run the test specifically for that. Now I'm going to come to one last point before I end this video, is that tests. This is something that I'm learning myself as I'm doing. So I come from a background of startups, tons of startups that I worked with. And in startups, generally speaking, that by the way, it has figured out already that we have support for GPT 5.1 codecs. So great. And how quickly does it do that? That also matters, right? As the project grows, you want to be able to focus, you want to be able to constrain how much access it has to all the files in the project. And the more you constrain, the better results you'll get, the clearer, the lesser the context the model will have to do what you want it to do. And in this case, because I'm in that SDK folder, right, it could easily figure out that I have already support for GPT 5.1 codex model. It just has to add the 5.2. Okay. It doesn't see that it is referenced. Of course, 5.2 is not referred in my documentation simply because my documentation is older than 5.2 release. Okay. So now coming back to tests, is that with tests, one thing I've learned is that unit tests are really a good way to, even if you're building APIs, even if you're building backends. I am slowly migrating. I used to have a lot of end-to-end tests, and this is very common in a lot of startups, that you just write end-to-end tests because you care about the outcome of the entire process, whatever is your pipeline internally happening. And that used to be great. But at the scale at which I generate code, and I generate a ton of code every day, like day after day, you can look into some of my comments. They have like mountains of code changes. Okay. Because I refactor a lot. This early stage in the product. So there's a lot going on. So if I do not have unit tests, what happens is that some of the end outcome, the API also changes. Okay. And of course, this is a constant, constantly, you could even say tiring process. But yeah, early stage, that is going to be the case, right? Because your product is not set in stone. You're going to change a lot of things. So now if I have unit tests, what happens is that I can easily isolate what are the things that will fail and what are the things that I expect to change, and then accordingly adapt the code. And this gives me better also, like when you see all my tests passing, is that it gives you more granularity into seeing like some small specific business logic which I know need to be tested, and it has to be tested exhaustively. I would rather focus on that and write like 5 or 6 tests. Of course, whenever I'm saying write, I mean the agent will write on my behalf, but it just makes it much better that way. And then I will probably put 2 or 3 really like concrete integration tests where I know that yes, I'm going to send this prompt, I'm going to expect this, that to happen, whatever, the API should come back to me. The rest of so that's like 1, 2, 3, maybe 4, maybe a few integration tests. The rest of the tests are more and more integration tests. And when you're building APIs, when you're building backends, then what I'm doing is that I'm using a bunch of helper functions, which means that the API handler, see, the API handler always is expecting some kind of an API state given from your framework or from your database or something else, the current user, right? But there is a certain business logic that the API handler is going to do. So what I do is I take out that specific piece of helping code, let's say helper code, and I stick it into another helper function or some helper file. And then what I can do is I can inject the parameters that I want. So some fake user, some fake, web state, some backend state, whatever, and then say, hey, do you do what I expect you to do? And then if the test for that is like, if you can think about it, like that becomes a unit test, that becomes much easier to test continuously all the time. And it's also much faster to run. The tests are much faster to run in this way. And then now you stick that helper function back into your entire like API handler. And then the rest of API handlers become much simpler because they become basically like take the current user, check authentication, check authorization, and call the helpers. That's it, done, right? So all the helpers have all the unique business logic, but all the API handlers do not have so much logic. This is very similar to the, like in a way, the compartmentalization of the model view controller system, if you think about that paradigm, because at the end of the day, your models, your views and controllers, right? So views are controllers. Views are like your handlers in a way. I mean, earlier days, views used to also produce HTML. Nowadays, we don't. We just produce JSON, but in a way, views are still views, right? They are basically API handlers. And then controllers were the real business logic. So controllers to me are helpers. And then I unit test the helpers. Okay. So yeah, these are like very high level stuff that I think I am learning, and it's giving me fantastic results. Again, this is relative. This is, my opinion. So please validate with, others who you're talking to or building with. But yeah, Also, if you feel like my way of doing things is valuable to you, you would like to get on a call and show me your project. If you're getting stuck on something, I'm definitely helping out. I'm doing more and more of these calls with founders who are getting stuck with coding with agents, and I'm happy to help.